Men all have this annoying habit of losing their footing whenever they see something big. To what extent does this happen? To the point where I even created a series specifically about it. Imagine a 1,000-ton steel beast hanging dozens of meters in the air, trying to fit into a millimeter-wide gap on a bridge pier. A single gust of wind shakes the beam just an inch, and hours of grueling work go down the drain. The master behind this impossible mission, China's self-developed mega-engineering titan, the Kunlun Smart Bridge Erection Machine. Welcome back, my hardcore crew. Every time you fly past on a high-speed train, have you ever wondered how those breathtaking bridges spanning seas and valleys are actually built? You might think, just use a giant crane. But here's the catch. Even if a crane can lift 1,000 tons, it can't anchor itself on soft soil, steep cliffs, or open ocean. And even if it could, lifting a 40-meter-long, 1,000-ton monolith dozens of meters into the air means sea breezes will turn it into a swinging pendulum. How could you ever lock it into place? That's why the Kunlun exists. But don't think it's just about brute strength. Its true superpower is conquering the most unreasonable, brutal environments on Earth. First, climbing steep slopes. It carries a 1,000-ton load uphill at a 30 per thousand. Gradient meaning it climbs 3 vertical meters for every 100 meters forward, all without letting the massive beam tilt or sway an inch. But its most mind-blowing trick? Tunnel crawling. High-speed rail routes weave through mountains. Once a bridge section is done, the machine has to pass through a tunnel to reach the next site. But tunnels are cramped. How does a 9-meter-tall, 1,000-ton colossus fit inside? Right then, it channels a real-life transformer. Its multi-story supporting legs retract backward, instantly squeezing its height from over 9 meters down to just 4 meters, belly crawling through the tight tunnel like a mechanical beast. Once through, it stands right back up. This isn't sci-fi, this is peak heavy industry engineering. However, the most heart-stopping moment is the final placement. Hanging 1,000 tons in midair and landing it within millimeters is a high-stakes thriller. Bolt holes underneath leave zero room for error, and any wind-induced deviation spells disaster. How does Kunlun stay rock solid? It uses an upper guide beam structure. The main load force pushes straight down like holding a shopping bag from the top so it doesn't swing around. Paired with laser radar tracking and micro-adjustments, the final millimeters require the operator to stare at the screen, holding their breath and inching it forward. Those few hours of landing feel less like operating machinery and more like performing open-heart surgery. And there's more than meets the eye. The heavy-duty welds bearing that 1,000-ton pressure are meticulously crafted, centimeter by centimeter, by master welders in blazing heat. Advanced tech and human grit, you need both to conquer the impossible. Next time you speed along at 300 kilometers an hour, look out the window at those sleek bridges and remember they were meticulously placed inch by inch by a morphing, climbing, tunnel-crawling monster of steel. Here is my question for you. Hanging 1,000 tons into a millimeter. Gap, what is harder to master, the top-tier technology or the operator's sheer nerve? Drop your thoughts in the comments and stay tuned for more mind-blowing engineering marvels.